Beneath the surface of the Earth, there are forces created by very high temperature and pressure. On the surface, the results of these forces may be seen in hot spewing geysers, bubbling mud pots, and volcanic eruptions. At certain places around the world where the Earth's crust is thin, openings or volcanic vents allow smoke and steam to escape, producing large clouds over the mountaintops. In other places, long fissures may open in the crust, permitting hot molten lava to spew forth in spectacular lava fountains. Large volumes of molten lava may flow down the volcano, threatening great damage. In February of 1943, a field in Mexico opened and a new volcano erupted. By the end of the year, the volcano, now called Paricutin, was 1,000 feet above the fields. For 9 years, the volcano continued to erupt. The average flow of lava was nearly 1 million tons a day. Then, as suddenly as they began, the eruptions of Paricutin stopped. Volcanic activity within the Earth's crust originates where local areas of high temperature from molten rock and gases build up tremendous pressure until the magma is forced out to the surface. The shape of a volcano depends on the kind of eruption and the type of lava. Cinder cones are formed by explosions that build low mountains of volcanic debris surrounding a central crater, which may later fill with water. These are craters of extinct cinder cones. They have been greatly eroded, yet the circular lakes remain in the central vents, which once boiled with molten rock. The sides of this crater are formed by material which was thrown out during an eruption. Over the years, wind and weather break down much of this rock. Inside the volcanic crater, we see vegetation which has grown in the soil created by this weathering and erosion. Angular rocks thrown out by explosions of the volcano are still strewn along the shores of the crater lake. There are other kinds of volcanoes which have very little explosive force. If the lava is thick and viscous, it may cool even as it is forced toward the surface. If it cools enough, it will be nearly solid when it breaks through the surface. This is called a lava dome. The resistant hardened lava may remain long after erosion has worn away the softer surrounding materials. Around a volcanic peak, there may still be vents of escaping gases and steam, indicating high temperatures and continued activity in the crust below. Of the various kinds of volcanic peaks around the world, the most common type is called a stratovolcano. It is formed by repeated eruptions which deposit layers or strata of ash, lava, and other materials that gradually form a tall, gently sloping cone. So many of the world's volcanoes are of this kind that the stratovolcano is usually thought of as the typical volcano. Mount Fuji in Japan is one of the world's most famous and characteristic stratovolcanoes. It has gracefully sloping sides and a relatively small crater compared with the size of the mountain. Like many volcanoes, Mount Fuji is high enough so that it is snow-capped for most of the year. The sides of stratovolcanoes are often deeply scarred by erosion. On an ancient volcano such as this one, the original slopes may have been greatly modified by centuries of erosion. Steep cliffs and deeply cut valleys are formed by the erosion of the alternating layers of hardened lava and soft volcanic ash. Such erosion exposes the interior structure of a stratovolcano. When volcanoes are formed with little explosive force and very thin lava, the lava may spread over a wide area, producing an extremely low, broad cone called a shield volcano. The entire Hawaiian Islands are made up of shield volcanoes, which rise almost 5 miles from the ocean floor. Some Hawaiian volcanoes are still active, and several have erupted in recent times. Long continued volcanic eruption causes withdrawal of large amounts of magma from the underground chamber, leaving voids within the crust. As a result, the top of the mountain may collapse, leaving an enormous depression known as a caldera. Later eruptions may form smaller cones within the caldera. These small cones are often seen as islands after the entire depression has filled with water. Caldera lakes of this kind are often exceptionally deep and clear. There are also many other topographic features which are not volcanoes themselves, but which are associated with volcanoes. On the steep slopes of many volcanoes, landslides of soft, water-soaked volcanic ash and mud are common. The soft debris may flow for many miles down the slope. The landslide may dam rivers or streams which lie in the valleys beneath the mountain to form a lake. This lake now covers a large area where villages once stood and farmlands were cultivated. The lake rose quickly after the river was dammed. So if we go underwater here, we can find trees and other things preserved beneath the surface. Here are the remains of a road which was inundated when the river was dammed. These are trees which were planted along the roadside. And this gate marked the entrance to buildings on the road. So, although this area was many miles from the volcanic eruption, it too was permanently changed by the explosion. This impounded lake is another topographic feature created by volcanoes. Crater lakes, geysers, bubbling mud pots, lava fountains, and spectacular volcanic peaks and craters. All these are evidence of the forces of heat and pressure within the Earth's crust, which continually help to shape our landscape.